Welcome to the Stanley Street Social Podcast. We're here in Freiburg in Germany for the release of the Cannondale Super. Sorry, I'm glad I don't have proper allergies. Here for the release of the SuperSix EVO. Firstly, we're just going to talk to Nathan Berry, who is a design engineer with Cannondale. We'll just talk a little bit about his role within the company, and then we'll get into the nitty-gritty of the bike. So how do you become a bike engineer, and what's your background?
How do you become a bike engineer is a good question.
I imagine you didn't sign up at uni to be a bike engineer, or did you?
No, not at all. I will say I've had an interest in it for a long time. I started riding bikes when I was about 12 and enjoyed physics and maths at school. So there was kind of a drive towards engineering, but the idea of being a bike engineer was pretty far-fetched from Australia.
Yep.
Not exactly a huge bike industry there. A lot of cyclists, obviously, but not quite an industry. So my formal education is as an engineer. So I did aerospace engineering at Monash Uni. I then went on to do my PhD in applied aerodynamics. So Monash University still does have an ongoing relationship with the AIS and helping our high-performance team with all of their aerodynamic evaluation. So we used to have a partnership and we did research, myself, and there was actually another candidate doing PhD research coupled with athlete testing and equipment testing for the AIS. So that got me very much engrossed into cycling aerodynamics, which is a pretty niche set of experience. And that happened to tie in nicely when I was completing my thesis. I was then obviously trying to find work both in Australia and abroad. And at that time, Cannondale were really overhauling their engineering resources. So there's several engineers that started around about that time, including my bosses. And so the company was really overhauling and bringing in a lot of new talent to help develop the next generation of bikes. And so it just happened to coincide nicely with my exiting research and sort of moving into industry.
So how long have you been involved with Cannondale now?
I've been at Cannondale for 3.5 years. So I joined at the end of 2015, just as the System 6 project was really ramping up.
So obviously in that 3 years, things have developed really quickly. What do you think has been the major sort of change from when you started to where we're at now within the industry as a whole?
I will say I guess the industry sort of is different compared to maybe what consumers see, because where I work and my colleagues in engineering work, we tend to be in the sort of 2 to 3 years ahead of whatever's on the market. Yeah. So Jonathan and I have been working on the Evo that you see now. We started work on that 2.5 years ago or something like that. So the timeframes are a little distorted there. The one thing I would say is just prevalence of things like disc brakes and just capability all round in bikes. Some of that has been a bit more progressive in America, but certainly in Australia, when I left in 2015, almost nobody had disc brakes on their road bikes. Everybody rode 23 or maybe 25 mil tires. Nobody was riding bigger than that. So it was still fairly traditional in terms of the equipment, whereas now that started to shift a lot, and certainly my perceptions around that sort of equipment has changed dramatically. I'd much prefer riding disc brake bikes, and especially with things like System 6, the things that we can do by using disc brakes give us so much more capability than what we would be capable of doing with rim brakes. And then you have like integration and all these sorts of things as well.
What do you think the main focus is for bike brands at the moment? Is there a specific focus that everyone seems to be focusing on, or are people doing other things? What's the trend in the market? I
guess disc brakes in a big way. I guess that's probably been going on a little bit, but probably will continue to happen. You'll probably see less and less high-performance rim brake bikes in general. Rim brake bikes probably still exist in sort of niche markets and introductory markets where it's just price is competitive. But certainly at the higher end, you're probably going to see more and more dominance from disc brakes. And then also like on the sort of gravel and adventure side of road, that's where things have really changed most dramatically over the last 3 years, of just the explosion of gravel as a category and what people are trying to do with a drop bar road bike that they were never considering 5 years ago.
Does every company seem to be doing the same thing and focus on the same things, or they kind of go in their own directions?
I think so. I think in general it's kind of it's kind of moving in the same direction, and people are just sort of interpreting those problems in slightly different ways on how they're going to tackle them.
And the bikes, how much faster can they go? Like, you look back only, I don't know, maybe 4 or 5 years compared to where they're at now, and the change has been remarkable. Like, what else can we do? Like, where do you see the future of bikes going? At the top level, the protein bikes.
Yeah, I think that's an interesting one. In terms of aerodynamics, we've made pretty massive jumps. So Cannondale sort of wasn't involved in, I guess, say the first 1 or 2 generations of aero bikes, if you consider, say, the Cervelo Soloist being kind of like the first one to come to the market. So we kind of skipped that in System 6, and that has taken like aerodynamics to the nth degree. The amount of drag that you'll be able to reduce within the current UCI rule limit is going to be fairly limited, but it'll be more just refinement, making things easy to work on and making them lighter whilst being as fast as they are now. And keep increasing capability. I mean, that's one of the things with the Evo now is it's still a race bike, but it's sort of so much better in every sort of aspect compared to its predecessor. And that's really where we pushed that. So I don't know. It's still evolving.
Do you think the UCI will change their regulations and drop the weight, and would that make things quicker?
It's really hard. I don't think most of the industry would like to see the weight stay where it is. No, I don't think many companies would like that weight limit to drop, because frames are approaching material limits in some regards. Like already on some of our bikes, like the down tubes and things like that, are only a few plies of carbon fiber where you just couldn't make it any thinner. So obviously there are some things you could make really, really light, but if you make it light enough, you're kind of regressing and you're taking away some of that aerodynamic performance, and overall that doesn't make a faster bike. So the other side of that is having this weight limit allows manufacturers to introduce a lot more technology into the bike. So like disc brakes, for example, you can now build very lightweight disc brake bikes. So you're seeing now, I think Quickstep and Bora and Trek are all racing exclusively disc brake platforms now, both their climbing bike and their sort of lightweight, their aero offering. And then the aerodynamics in general. So like deeper wheels, deeper tube sections, all those kinds of things can now be built into a bike that meets UCI limits or above that. Like most race bikes are not at the 6.8 kilo limit. So personally, I would hate to see that go away, because it gives the pros the excuse to try and make lighter bikes, and they'll probably be slower. And the people that figure out that science will be the ones that capitalize the most. So hopefully it stays where it is and we can continue to evolve technology and integration within the packages that we have.
So how are they going to get faster? Do you think is aerodynamics that's the main thing that makes a bike faster?
Yeah.
100%?
Yeah, so if you're talking about like race speeds for especially pro guys, 45 to 50k an hour, drag is at least 90% of the total resistance, because you're talking about bikes with good tires and good bearings and all that kind of stuff. And at that sort of speed, the weight doesn't make a lot of difference as you kind of go up and down a couple of percent, say, and you're just at high speed racing. And then as you transition towards big mountains, big alpine climbs tend to be around 7%, 8%, something like that for a tough climb. I think Alpe d'Huez is like 8.3%. So if you take a good example is like System 6. We talked a bit about this last year with the launch of that bike. Compared to the Evo 2, so the lightweight round tube bike, there's about a kilogram difference in weights, say like 6.8 to 7.8. And then there's a huge difference in drag. And what that means for the rider is that on any gradient up to about 6%, if you're a rider at say 4 watts per kilo, up to 6%, the System 6 is faster. And then only above that does the lightweight bike actually give you any advantage at all. So in that scenario, you could have a bike that weighs 6.8 kilos. Unless you're going over 6% grades, you're slower. So if you're on 4%, 5%, the heavier bike is actually going up the hill faster. And that's a concept that's still really foreign to cyclists. I mean, cyclists have been obsessed with weight for 50 years, 100 years. Like, it's been all anyone's thought about.
Yep.
So that is a big paradigm shift. So even though we've kind of had some introductions of aerodynamics, that concept hasn't been grappled that well. Even now, it's still pretty new to a lot of pros that are racing, the concept that maybe the heavier bike is the faster way to go. So, there's that. The other thing about those aero platforms is that they're now much more complete bikes. Like earlier generation bikes kind of sacrificed so much performance across the board. Like they were heavier, they weren't as stiff, they didn't ride very well, the geometry was
mechanics
compromised.
nightmare.
Yeah, so there was just all these things just to get the aerodynamics. With the sort of latest generation of those bikes like System 6, they're not as hard to work on. The stiffness is exactly the same. Like head tube bottom bracket stiffness is the same as our Evo 2 because that's the benchmark. They're not so uncomfortable to ride anymore, so you don't have to make all the sacrifices, but you get the speed. And now we're getting even more speed. Like since the say Venge Vias like 2015 got introduced, that was like a big step over the bikes before that, and that's kind of the space that we're operating in now.
Let's talk about the SuperSix EVO.
Yeah.
Firstly, what was your role in developing this product? I imagine you are in the thick of it. You are the brains behind this.
So I guess SuperSix EVO was a real collaboration between myself and Jonathan Schottler, the senior design engineer. So I tend to do a lot of the aerodynamic evaluation and investigation, and then work with him to flip that around and be like, how can we make this structurally optimized? So I did a lot of sort of very initial research work on how do we go about making a bike that is lightweight, has balanced stiffness in terms of like lateral and in-plane, and keeps a classic aesthetic. So, in profile view, it needs to look like a classic bike without these deep tubes. So I did a lot of work just investigating different tube shapes and layouts and, which parts of the bike contribute the most to drag. How do we take those shapes and make them work better? So I sort of developed this family of shapes and this framework that we could try and pick from, and then transplant that into the morphology of a bicycle and say, all right, what can we do with this to make the stiffness work and the layout work and then all the other stuff? And then sort of take it from this concept into an actual bike and then go from there. And the initial concepts, as a frame worked out really well when we're doing CFD evaluations. So we were pretty confident that these concepts were working. The other things then is I also worked on the wheel set. So this bike has its own unique wheel set. So the new Knot 45, so a 45 mil deep wheel that's 32 millimeters wide. We came up with a new rim profile for that to, try and minimize drag while still working with the sort of tires that people want to ride on bikes like this. So I think I designed it around a 28 millimeter tire.
Okay. So the main focuses of the bike are lightweight and aerodynamic.
Yeah.
and
and stiffness.
That's the three things.
Yeah, I mean, it's kind of the holy grail, right? We wanted something that, I guess, if you step back a couple of years, you kind of had to choose do you want lightweight and optimized stiffness, or do you want aerodynamics? So with System 6, we have, fully pushed the aerodynamic. If you think of it like sliders, you're like, all right, we're dialing this all the way up to 11 on aerodynamics, and we can sacrifice some weight. But we have to hit stiffness. We actually benchmark all our road bikes have to hit around about 95 Newton meters at the head tube and per degree, and 65 at the bottom bracket. That's kind of where Evo 2 landed, and that tends to be what most people find is sort of optimum in terms of handling and out of saddle and cornering and things like that. So that's kind of like day one is like, it has to do this.
Yep.
If you don't do this, we fail. So you sort of have aerodynamics for System 6, and with Evo, we wanted to be like, all right, we want a lightweight race bike that appeals to the classic racer, but we need to bring aerodynamics into that. So it was really, how do we take that classic race platform, which is really what Evo 2 represented a kind of the pinnacle of, and bring that forward with modern technology and update it to deliver the capability that a rider demands. So it's like the classic race bike for the modern rider. So it's got bigger tire clearance than ever before, it's more compliant than before, and it's got much less drag.
So the finished product, why is it is it? I think in the presentation you said it was the most aerodynamic bike on the market. Is it?
Of what we have tested.
Your
so
research.
We've tested sort of what we consider the primary competitors. So Cervelo, Specialized, Trek, and BMC. And out of those, it's got the lowest drag by a significant margin across the yaw curve. So it seems like we've achieved our goal. The goal set for us from David Devine, our product manager, was he said, I want the fastest lightweight road bike. So we had to, keep the weight where it was and just take as much drag off as we could. So it seems like it worked.
So what are the main things you need to look at? Looking at the finished product, what makes it so fast?
The tube shapes help a lot. So those tube shapes, and working with Jonathan to kind of characterize this. So, I mean, a good example is the down tube. It's exactly the same circumference as the Evo 2 down tube. And basically we're just redistributing where that material is to reduce drag without giving up stiffness. So I think the frame and fork alone at 48k an hour, which is we test in the wind tunnel at 30 miles an hour, so 48.3k for the rest of the world, but I work for a US company, so we have to talk in miles.
Yeah.
At that speed, I think the frame, fork, seat post alone, just the frame module, is 20 watts less drag than the previous bike, but it weighs exactly the same. So it's, a lot of work just in optimizing the shapes.
And obviously the integration as well was a big focus.
Yeah, so so the cockpit adds quite a bit to that. The integrated cockpit's worth about 9 watts at that speed compared to, your conventional round stem, round handlebar setup. Cockpits are a big deal. That's why you see on sort of modern race bikes, all of the aero offerings across the board now have integrated or at least airfoil shaped handlebars, because there's just a huge amount of drag coming from the cockpit, and if you want to compete at the pointy end of that, you can't do it with a round bar. So
you're involved with that development of that technology, or is that someone else that works on that?
Yeah, so we have a dedicated components engineer, Dennis Kerner, and I work with him on rim development and component development as well. So the handlebar for the System 6 has a purely airfoil shape. It's very aerodynamically optimized. The shape on the Evo is actually more of an ellipse. It's designed more around rider comfort on the tops, because it's sort of a more all-round bike, but it is flattened. So it's kind of this nice elliptical ovalized shape that's sort of nice to the hands and ergonomic, but also has the benefit of being lower drag.
What's the idea behind the low seat stays? Obviously, it provides a little bit extra comfort, but from an aerodynamic point of view, is there benefits for that?
Yes. So dropping them for comfort just basically allows the top part of the bike to flex more. So it's sort of rotating around this seat stay attachment point. So it allows everything above that to kind of rotate a little bit. And if your seat stays run straight into the top tube, you're kind of limiting that motion. From an aerodynamic point of view, lowering them just means you have less seat stay. So there's less projected area to the front, and there's less material that the air has to move around. So it just makes it more efficient.
So developing this bike, did you work closely with the pro team riders at all?
We certainly take their feedback into account. So we knew how much they loved the Evo 2. And so that kind of gave us good guidelines of what we had to achieve with this new bike. It had to be at least as good as the current bike in all of its riding characteristics, and then everything else we did to it was kind of on top of that. And then we did do some ride testing with the team before we went into final layups. So we sort of took them blind tested samples of different carbon layups of the frame and the fork, and we sort of had what we thought was the optimal solution, and we wanted to see if they agreed and if they could detect some of the differences between different versions. So that was kind of before we pulled the trigger on final mass production. So end of last year, we sort of gave them a couple of riders to test some bikes, and after their feedback, we were able to go into manufacturing at full speed and say, yep, this is the version that we want.
As a consumer, why would I buy this bike? Like today I was riding it, and I've never been on a bike a few downhills over 50k an hour that you can actually feel that it's fast.
Yep.
Like it just wants to keep going. Is that the main thing that you're trying to encourage people to buy this bike, because of just how quick it is?
Yeah, I mean, that's the aerodynamics at work. I think the thing with aerodynamics is it's hard for some people to grasp it because you can't feel it statically.
Yeah.
Excuse me.
That's right.
America, don't call me now. Right. So one of the things with aerodynamics is that it's difficult to grasp if you're not an engineer and you don't sort of like what's the deal with aerodynamics? As we sit here, you're not feeling the air doing anything. Whereas you can walk into a bike shop and pick up a bike and be like, hey, this is pretty light. And so there's this dichotomy of like, it's really easy to understand weight. It's very difficult to understand aerodynamics. So people naturally gravitate to the thing that they understand, but it's not necessarily the most significant. The other thing is speeds. So if you're just cruising along, you know, often it's like riding at 30 kilometers an hour. Most people can kind of do that. And then because aerodynamics scales with velocity cubed, so aerodynamic power is scaling with velocity cubed. If you double your velocity, your power goes up by a factor of 8. So the faster and faster you go, these things just kind of get massive. And that's why when you go down a hill, you suddenly start to feel it, because on a high drag bike, you just hit terminal velocity where you're not accelerating anymore. And on a low drag bike, you just keep going. So here in Freiburg, there's a lot of big mountains, and the local guys here tell me that they're considering putting bigger gears on their bikes because they can now go so fast down the hills that they're just spun out on a 53. So they're going to 54s if they're trying to chase downhill KOMs.
Because I've never felt that on a bike. I've never ridden an aero bike.
Yeah.
But I actually felt today that the bike just wanted to keep going. I was like, this is really cool. When, like you said, it's something that you can't judge in a shop by just looking at it. You actually really need to get out and try it.
Yeah, and that was one of the things with System 6 that happened a lot. Even at our company, you know, we had this history of light and efficient climbing bikes, but aerodynamics was not such a strong technology stream for us. And so when I showed up and started talking about these numbers and how much faster it is, people were like, that can't be true. You can't really be that much better.
Yeah.
And then people go and ride the thing and you're like, oh my gosh, like my average speed is 2 or 3 kilometers an hour higher.
Yeah.
And like you do really feel it, especially
sure.
like pushing over hills. Like you just notice as soon as the road tips down, the bike just wants to go for it.
Yeah.
And that's the aerodynamics at work. In the case of the Evo 3, it's nice because you get a lot of that. I mentioned in my presentation, like we're starting to push into the realm of what some people would classify as a dedicated aero bike in our climbing like all-round platform. But you also get the rest, so it still has this nice classic profile. The wheels are 45mm deep, which is just a really nice balance between sort of handling in crosswinds and aerodynamic performance and weight. So overall, it's just a really balanced package and very capable. So it'll fit at least 30mm tires with 6mm of clearance.
Wow.
So you can run pretty big rubber in there, you know, all the way up to people that probably want to ride on some unpaved roads. You'll be fine on this bike.
Cool. I also noticed today that it's super stiff.
Yeah.
I'm not a sprinter. I never was a sprinter, but I just noticed that there's no power being missed out. It's all just going straight through the bike. How's that developed, and what's the ins and outs with creating a really stiff bike?
So most of that is in the bottom bracket stiffness and the head tube stiffness, so how much torsion you're kind of getting. So you usually feel those when you're out of the saddle, or head tube stiffness you also kind of feel at fast cornering. And yeah, basically with sufficient stiffness, it just makes the bike feel very direct, both in steering and in power response. And so that kind of comes back to that was one thing that a lot of people liked about the second generation Evo, and it was really responsive and it handled beautifully. And so those were kind of the benchmark numbers that we had to hit, because that's what people liked about that bike and we all like about that bike. And so we knew that the new one had to be at least that good, and that's what you're feeling.
Nathan Berry, thanks very much for joining us on the podcast, and thanks for creating such a fantastic bike.
No worries.
Cheers.